Jai Hind everybody. In the first lecture, we have discussed what was blockchain. Now we will discuss how we can implement those particular blockchains. In the last video, we have seen that a blockchain is a distributed environment, and we have an authoritative domain which is given to each and every nodes which are being connected in that particular domain. So here I have taken the example of we have node N1, N2, N3, N4, N5, N6, and N7. So we have 7 nodes in this particular blockchain. Whenever, assume that N5 is making some changes in the document. So whenever that particular N5 is making a changes, it would first make a change in the local copy. Then it would distribute that particular information, updated information to each and every node, so that N1, N2, N3, N4, N6 and N7, all those particular nodes have a synchronized copy of that particular updation which was done by N5 node. So this is a simplified version that first the node makes a change in the local copy, and that particular local copy is synchronized with all different local copies of the system. So this is called as the public ledger. So the public ledger usually is a database which keeps the historical information which is available to everyone. See, what we have seen, that if N5 is making changes, then it would obviously distribute this particular changes to each and every node. So we are keeping a historical information of what all that particular thing and which particular user has made that particular changes. And that historical information is utilized for future computation in blockchain. How we use that in the future, we will see in few slides coming. See, for example, whenever you are looking into that last 10 transactions, have you ever seen the last 10 transactions which were done in the bank statement? So in that particular thing, we see only 10 transactions. All these particular transactions are being validated by our bank server. It is keeping the history of all that particular information, the all transaction which was being done. So whenever we are doing a new transaction, then that transaction is being validated. What do you mean by validation of that particular transaction? Assume in my bank account, I have 50,000 rupees. Okay. And I told that I want to transfer to my friend 70,000 rupees. So is this a valid transaction? No, because I don't have that particular amount in my account. So this becomes an invalid transaction. So this transaction, when we are actually doing this on internet banking, or when we are withdrawing from the bank, we see that this particular human involvement is not there. Only the system is doing that particular update. I have entered 70,000, but they are comparing the balance with the current amount. If that is balance is less than the amount which is being entered, then obviously it is an invalid transaction. If balance is more and the amount entered is less, then the transaction is valid. So first step is we are validating that particular transaction using the old transaction. Because the result of the old transaction was, what is the balance in my account? This is my account balance. So that was the result of my old transaction. So old transactions are used to validate this particular new transaction which I was going to do it. So obviously we have to keep this, and this is done by bank server. So if this is done by bank server means I require a centralized server or a centralized body which would take care of these things. But I don't want this in terms of the blockchain. So we want that each and every node should keep that particular history and tell if this particular N5 is doing such invalid transaction, that it has only 50,000 in the account and transferring 70,000, any one of this particular user, anyone except N5 would let them know that this particular transaction is invalid. So we don't only want a central authority so that can tell us that we are doing something wrong, but anyone in that particular group has the authority, that is equal authority to give us that particular advice or tell us that the transaction which you are doing is illegal. So we can take this particular example. Assume that we have four customers which are in this particular blockchain. These are 4 nodes. One is Alice, second is Bob, third is Eve, and fourth is Jane. So see, this is my public ledger. This is public ledger of each and every user. See how this gets updated when we are doing changes in this particular blockchain environment. Okay, so I would be taking 3 different transactions which we are doing among themselves in this particular public ledger environment, in this particular banking sector. So all these 3 are telling, all these 4 public ledgers are telling Alice has rupees 100. Okay, no information about Bob, Jane or Eve. Now I want that Alice should transfer rupees 50 to Bob. First thing, Alice has to transfer rupees 50 to Bob. So a line would be added, Alice to Bob rupees 50. In her ledger, in her public ledger, I am writing this in short form, Alice to Bob rupees 50. Again, Alice to Bob rupees 50 and Alice to Bob rupees 50. So this particular transaction is being added. First, what we will do? First, we will validate this. Does Alice have that 50 rupees to transfer it to Bob? Alice has 100 rupees in her account. So yes, she can transfer it. So this transaction is successful, and in this particular transaction you can see what is the changes in each and every public ledger. We have added a record after Alice has rupees 100. So all the users Jane, Eve, Bob and Alice, they have their local copy of the public ledger, and it is getting updated when that particular transaction is being fulfilled successfully. That transaction is being completed successfully. Okay, now see, now if I tell that Bob wants to transfer rupees 30 to Eve. Bob, previously there was no information about Bob's money, but now I know that Alice has transferred 50 rupees to Bob. So now Bob has 50 rupees. I know that. Everybody in this particular blockchain knows that Bob has rupees 50, which he can give to anybody if wants. So he want to transfer rupees 30 to Eve. So this transaction becomes valid because Bob has 50 rupees. So now a line would be added. I'm again writing in the short form. Bob sends to Eve rupees 30. Again, Bob sends to Eve rupees 30. Here also, Bob sends to Eve rupees 30. And here also, Bob sends to Eve rupees 30. So see, the size of the public ledger is increasing, and we are only adding the transactions which are successful transactions in this particular thing. Now see, now Eve has 30 rupees and the Bob is left with 50 minus 30, that is 20 rupees. Alice has 50 rupees. Now again Alice told that I want to transfer rupees 70 to Jane. But as she tells that she want to transfer rupees 70 to Jane, everyone knows that Alice has rupees 50. So they would notify that this is an invalid transaction and this cannot take place. So this invalid transaction won't be added to our public ledger. Our public ledger would have only copy of those transactions which are successfully completed. Okay, so public ledger is each and every user have a local copy of it. If the transaction is being done, then that particular transaction entry is being done in each and every cases. See, here we have taken an example of only 4. If I have thousands of users which are there in this particular public ledger example, then when we are doing a one successful transaction, then we have to update all those 1,000 public ledger, so that each and every node participating into that blockchain has a synchronized copy of the transaction which was being done. Okay. So what we are doing it, so blockchain is a public ledger. I think public ledger might be clear at this particular point of time. So now we have a protocol for commitment. So what does this protocol of commitment mean? We have to see the validity of this transaction. So if the transaction is valid, proceed. If the transaction is invalid, then decline it. So we have to ensure that the transaction which is being done is successful, or it is a valid transaction, then we will commit that particular transaction. In database, commit is we are fulfilling or we are successfully completing that particular transaction. If the transaction is valid, then we will commit that particular transaction. If that particular transaction is invalid, then we won't commit it. We won't make those particular changes. So while first is we should have a protocol of commitment. It should be there in each and every individuals which are being involved in that particular blockchain. Second comes, next point is the consensus. Obviously, when we are I have made these particular changes, and at each and every point when this particular transaction was being done, there was an agreement or there was an understanding between these two. If I tell that Alice is sending rupees 70, so all of them would say, or anyone can raise the voice and say, no, we cannot do that because she doesn't have that money. So we don't have to wait for that particular person, because we have to have a consensus, a surety for each and everything. So we should have a local copy which is consistent, or that I should say that should be same or similar on each and every node. If it is not same and similar, then obviously there is no consensus. Somebody is doing some forgery, or that person is a culprit and creating some nuisance in that particular network. Then we have to see the security aspects, that the data which we are sending should be tamper-proof. We have a decentralized system. We don't have a centralized system. We don't have a central authority. We have a decentralized system, no central authority to take care. So we have to develop that particular system so that the transactions which you are doing, the changes which you are making should be tamper-proof. Nobody can compromise this particular data. Means the data which is being entered, once done, should be freezed off. Nobody can change those particular things. So that is, we should have such a record that it should not have a malicious attack, or we cannot compromise this particular data. We cannot change any of the bit in this particular data. While doing this, we have to keep into mind the privacy and the authority of various clients. We don't want that particular private information of that particular client should be given to anybody else. So for example, for privacy, we can tell that your mail ID is known to everybody, okay, but your password is not known to everybody. As it is, if you protect your profile also, then your personal information won't be seen to any of the users. So similarly, we are knowing who all taking part into the transaction, but we don't know exactly what are the personal details of that particular person who is taking part into that particular transaction. Similarly, we have to see the authenticity, the work which the person who is doing is an authenticate user or not. So blockchain and public ledger. The concept of public ledger came because we wanted that the centralized banking server, if that particular server gets failed for the problem of the centralized or decentralized, then we have to wait. And here we don't have to wait. If one of the person gets failed, then that particular chain won't be taking part into the transaction. Otherwise, other 3% can take part into that particular blockchain. So the blockchain has a concept of public ledger, that is, local copy of each and every transaction is being synchronized on each and every nodes. So the keywords which we basically used in open for the blockchain is, one is open. Open, that is, it is accessible for all. We don't require, like if I don't have an account in that particular bank, consider PNB Bank. If I don't have an account in PNB Bank, why would I access that particular server, or they won't allow me to log in into that. But here, anybody can come and become a part of that particular blockchain. So it is open for all. It is accessible to all. Then we have discussed distributed or decentralized. That is, we don't want a centralized system or a single point of control or a single point of failure also. We want that it should be distributed. It should be equally likely. The authority should be divided, and each and every person should have an equal authority in that particular domain. And so we can see the efficiency. As I told, anybody can come and access it. So it is fast and scalable. We can increase that particular thing. Okay. Then comes the versatility. Verifiable is everyone can check. Here we are checking that particular transaction of Alice transferring 70 rupees. That was not valid transaction. So anyone in that particular network can verify that validity of the transaction or validity of the information which is being transferred in that particular blockchain. Once made, cannot be changed. So the information is persistent or permanent. We cannot change the information once it is done. That means the information becomes tamper-proof. We cannot have. In other words, I can tell these particular information are immutable. Like we have strings are immutable in Java. That is, whenever you want to create a new string, then again a new copy would be created, but we won't be changing the same copy. So here I can tell the blockchain records are immutable. Okay. So the blockchain basically comes, what structure this blockchain uses. Blockchain is like a linked list. What does the linked list means? Everybody might have studied that in data structures. In linked list, practically we have two parts. One is the info part or the data part, and another is the pointer to next. Okay. Then with this pointer, we are connected to node 2. If this is node 1, this is node 2, then we are again connected to node 3. Okay. So this is the pointer, this is info. So we have different nodes which are being connected to one another in this particular linked list. So we are replicating. What we are doing it? We are replicating this particular information. See, that particular node is being created each time. We have to create, like if you use an struct node, we are creating a new node and then appending it at the end. We are appending it in the end. Obviously, when we are doing it, we are appending at the end only, unless we are inserting at some specific position. So it is a linked list. So blockchain is a linked list data structure in which the structure is being replicated. So see, this structure was being replicated on each and every node. Same structure was there on each and every node. So we are replicating that particular node, and that node is again, we are having that particular distributed. It is on each and every node. Each and every node we have that particular local copy. And then we have a consistency. Obviously, this consistency is by the agreement between each and every nodes which are taking part into it. So then it comes cryptographically linked. We will come to this particular point in coming slides. Cryptographically is because basically we want it should not be in the same format. Crypto is, we are hiding something. We want that the words which we are sending, like I am sending my password. If you see that particular password, it's not, unless and until you tell it show, it is always in the asterisk format. Why? Because we don't want any person who is standing behind us should see that particular password. Okay, then when we are sending this password to the server for verifying that you are a valid user or not, at that particular point of time, we are not sending this particular password as it is. For example, I should say, like you might have studied in logical reasoning, if I have a value of A, B, C, D as a password, then we usually send it in some different format. Like see, if I'm using +3, then I would be having E, F, G, H. That is 3 characters ahead of A. I am sending it. So I won't be sending it A, B, C, D, but I would be sending it E, F, G. And then at the server side, it would again be doing -3, getting this particular ABCD, and then verifying that I'm a valid user or not. So when we are sending this particular critical information, we want that information should be secured. Nobody else should listen. Whenever a listener or a hacker listens to this particular link, they should not get that particular information as it is. So we want that we should assure the integrity of the data. We would be coming in detail for this particular cryptographic links. So obviously a linked list, it is a set of blocks which is connected. There, which we have discussed, we have here the addresses which are being pointed to the next means addresses. This addresses is getting that changes. The pointer is basically the memory addresses. But in the blockchain, it is a distributed data structure. We are replicating the nodes and we are not linking it by the memory addresses, but we are linking it by the blocks. One block is being overcome by the another block. So it is basically a series of blocks, and each block is connected with the previous block. So I have a block 1, it is being connected with the block 2, and this block 2 is again connected with the block 3. So in this, it is being connected with the previous block. So how do we connect this? We have a special links, and we use these particular special links as the hash keys. Now it is replicated over. So how it is? We have different advantages of replicated. Like if I have one replica is corrupted, or I told you that if you're keeping a backup of that particular thing, means when I'm keeping a backup, whenever the server fails, what we will do it? We will get that particular server data back or loaded on the server. Till that particular point of time, my server will remain failed. And when that particular database is being loaded up, then I can again have that particular normal working of the server. So integrity of the information is contained in the data structure. So we have to see whenever it is being replicated, we are guaranteeing that there would be integrity, there would be consistency in the data. Nobody else can update that particular information. If it is being updated, we are loading that particular data, and we will get that particular data in a consistent manner. Okay, so then it's distributed. Obviously distribution, it is actually running on the distributed algorithm. So we should have a data consistency and integrity. So obviously when we are looking into the consistency, basically we should have a consensus. Each and every node should have an agreement into that. They should agree on what they are doing it. If they don't agree, then obviously we cannot add that particular block. So in the coming videos, we would be discussing about how this particular blockchain blocks are cryptographically linked, because as cryptography is wholesomely a new topic which we have to consider into this. So we should have an agreement among the nodes. We should have replication, distributed data, and the linked list structure. These are some of the characteristics, how it is cryptographically linked, how we can have that integrity into that particular data. We would be discussing into the next video. Thank you.